you want to be healthier, yet you just don't know what to do? All these shows telling you this and that, but nothing seems to work. Well, listen close. Golden State Media Concepts has got something great for you. The Health and Wellness Podcast dedicated to workout trends, healthy eating habits, diet, and everything about healthy living. Join us in our banters as we help you not just live life to the fullest, but live it to the healthiest.
The GSMC Health and Wellness Podcast, brought to you by the GSMC Podcast Network. I'm your host, Alex. Today we're going to talk about electricity. It plays a big role in health and wellness, whether you are using the electricity within your body to move your muscles or other forms of bioelectricity, or even using electricity for therapy, like in the case of TENS units, or if you're just paying more attention to how much electricity you're using in your day-to-day health and wellness pursuits. In the modern age, there are many different ways that energy in the form of electricity can really have an effect on your health and wellness. And we're going to talk about several of those today. First up, as you guys know, is my preference. I like to go ahead and define some stuff for us at the beginning so that we can know exactly what we are working on as we progress through the episode. From laying on my parents' front porch as a little girl and watching lightning storms, to reading about Nikola Tesla and his biography as an adult, electricity has always fascinated me. So let's really talk about what it is, what it does. Electricity is first and foremost a type of energy that can really build up in one place, or it can flow from one location to another. If electricity gathers in one place, that type is static electricity. And we think of static as being something that makes our hair stand on end. But really in science, for the most part, static just means that something doesn't move. So we have static, things that don't move, and then dynamic, something that does move. So those are kind of the binary opposites that are used a lot in different types of science to refer to whether something is moving or not. So static and dynamic are like not moving and moving. So electricity that moves from one place to another is called current electricity. It's flowing like a current in the ocean, right? So that's the way that we're going to think of that. Static, sure, it's also the kind that can make your hair stand on end, but it really means it's just kind of chilling in one place. And current electricity means it flows like a current. So lightning is kind of a form of static electricity. Lightning happens when that static electricity turns to current electricity. It's when it goes from not moving, it's just building up in one place, and then goes to flow from one location to another. It often happens when you rub things together. So if you rub a balloon against your hair or against your shirt 20 or 30 times, it very well may stick to you. But why does it do that? Well, that's because rubbing that balloon gives it a little bit of an electric charge, which is just a small amount of electricity. So that rubbing of the balloon, giving it an electric charge, makes it stick to whatever it is you have been rubbing it against, because that item gets an opposite electric charge. So if you're rubbing it on your hair or on your shirt, then they're going to essentially be attracted to each other like the opposite ends of two magnets. If you've ever been in the grocery store and touched something metal like the grocery cart, this happens to me quite a bit, and you feel a little bit of a zap, that is an electric shock. It's just a very low-level electric shock. When you walk across a rug or a carpet and your socks are rubbing against it, then your body can gradually build up an electric charge. And then that's the little tiny zapping or tingling sensation that you get. If you're touching the metal in the grocery store, that is the charge running instantly to the earth. And that is what is resulting in that shock. In the case of lightning, as those rain clouds are moving through the sky, they're really rubbing against the air around them. And I know it sounds weird to think of clouds rubbing against air or the sky, but we see them being moved around more or less by the wind, right? So they are able to interact with that environment around them. And as they do so, it builds up a huge electric charge. And when that charge gets big enough, it really ends up connecting with the earth as a bolt of lightning. And you can feel that tingling sensation in the air when there's a storm nearby. That's just because of the electricity in the air around you. It's just building up. Now, if you're sitting here thinking, wait, Alex, I thought that in the case of lightning, it comes from the ground up. Well, lightning strikes from the sky down and from the ground up. So remember how we were talking about those opposite charges when it comes to static electricity, and how if you're rubbing a balloon against your shirt, one item is going to get the positive charge and the other the negative, and they'll be attracted to each other like a magnet. The same thing kind of happens with lightning. So the cloud to ground lightning does come from the sky down, but the part that you're able to see is that visible flash is coming from the ground up. Most forms of cloud to ground lightning are really lowering an invisible path of negative electricity. So we can't see that part, and that's going down towards the ground in a bunch of different spurts. And then the objects on the ground are typically under the influence of a positive charge in most cases of thunderstorms. So it is the positive charge that we're able to see from the ground rising up to meet the negative charge that is being shot in these little bursts, more or less, from the sky. But the parts that are coming down, the negative components, are invisible, and the positive components are visible. So this happens really fast, and because of the way that it happens and the limitations of the human eye, it appears to occur in a very specific way. But honestly, it's just happening so fast that when that negative charge and that positive charge meet, that return stroke is zipping back up into the sky like a very erratic zipper, more or less. And it's that return stroke that is giving you the visible flash. But it happens so quickly that we just can't really recognize it. But natural lightning can also trigger discharges up into the sky from tall towers, like broadcast antennas or other types of large metal poles. So lightning is, in that way, acting very much the same as rubbing a balloon on your body. It's just to a greater degree. But they're both forms of static electricity. And electricity in general is caused by electrons. So these are tiny particles that really orbit around the edges of atoms. Everything is made of atoms. And we have those three different types of charges in those particles. We have protons, neutrons, and electrons, just to keep it simple. Neutrons, neutral charge; protons, positive charge; electrons, negative charge. So each of the electrons have a small negative charge. And an atom normally has an equal number of those negatively charged electrons to the positively charged protons. So atoms typically overall have no electrical charge because they're canceling each other out. And that's the case for a lot of materials, like rubber. They don't have an electrical charge in the molecules of rubber because their atoms don't have electrical charges either. So the resulting material doesn't have them. But if you are rubbing that balloon on your shirt over and over again, and when you move that balloon backward and forward, you're giving it energy because your hand is moving it. And as that rubs against the material on your shirt, some of the electrons in the rubber molecules on the balloon are really jostled free, and they're gathering on your body. And that's leaving the balloon with too few electrons. And since those are negatively charged, now that the balloon has not enough electrons, it still has those protons, and so it is more positively charged, just by a little bit. But your shirt has those extra electrons, and so it's negatively charged. And so when that happens, you have one item with a positive charge, the balloon, and then the shirt with the negative charge, and it's causing them to be attracted to each other and to more or less stick together. That's really a TLDR for static electricity. And we're going to go on a quick break. When we come back, we're going to talk about current electricity to lay the groundwork for the rest of this episode. Stay tuned.
Are you looking to learn more about the latest trends from the fitness world? Are you confused by all of the different trends that are out there? The GSMC Fitness Podcast is the place for you. The GSMC Fitness Podcast is the place to come for people of all skill and interest levels. Join us as we explore the latest trends in the fitness world. Does that new exercise really work? Should I try yoga? Whatever your question, chances are good you'll find an answer on the GSMC Fitness Podcast.
We are introducing the concept of electricity and how it particularly works with lightning and the concept of static electricity. Now we're going to focus on the other type of electricity, which is referred to as current electricity. Remember, static means that it is not moving, it's just building up in one area, and current means it's moving like a current in the ocean or the water. So when electrons move, they carry electrical energy from one location to another. And we refer to that as either current electricity or an electric current. A lightning bolt is one example of an electric current. It's a very brief one, and it happens when you are getting the static electricity changing into being current electricity. It's going from not moving to moving. But these electric currents are also involved in powering the items in your house that use electricity. So your washing machine, your flashlight, your phone, your laptop, lamps, lights, anything in your house that uses electricity or any type of power, as we think of it, is getting an electrical current or an electrical charge. And that also includes things that run on batteries, not just things that plug into the wall. You may also be familiar with the terms potential energy and kinetic energy. Potential energy is the type that's stored somehow to be used in the future. A car that is parked at the top of a hill has potential energy because it has the ability to roll down the hill in the future. And while it's in the process of rolling, that potential energy is converted into kinetic energy. Kinetic meaning moving. In that way, potential energy and kinetic energy are really similar in concept to static electricity and current electricity. So when electricity gathers in one place, it has the potential to be used for something in the future. Electricity stored in a battery is one example of that electrical potential energy. And you can use the energy in the battery to power your remote controls for your television or your video game console controllers. All of those are examples of that. And when you switch on the remote or you go ahead and switch on the controller, the battery inside is going to supply electrical energy to it and help it start working, help it come into contact with the other machines that it's controlling. And once the item is turned on, the energy is flowing from the battery to those other components. And over time, the energy that's stored in the battery is discharged. It's being used up, and then that battery more or less dies or runs flat. And you either have to replace it, or if it is the type of battery that can be recharged, recharge it. Now, for an electric current to occur, for the electricity to actually begin moving, you need a circuit. A circuit is just a closed path or loop around which an electric current can flow. So just think about a circuit in regards to circuit training. So circuit training or an exercise circuit is just completing all the way through one of each of the sets of exercises. And then you're going to do those sets again in that same order. Kind of like going in a circle or truly a cycle, which is what circuit training is truly referring to. And the same thing works here. So it's essentially going in more or less a circle, but it doesn't have to be circular necessarily. But you do have these connections, and it's a path for the current to flow through, and it needs to be closed. A circuit is made by linking electrical components together with little pieces of wiring. And in a flashlight, you'll see that as having a simple circuit with a switch to turn it on and off, the bulb or lamp area to give you light, and the battery. And there's a few little pieces of wire in between there and little pieces of metal. So when you engage that switch, you hit the button to turn the flashlight on, electricity flows around that circuit. If there's a break or a gap somewhere along that circuit, then electricity can't flow. It'll be interrupted and the lamp will not turn on at that point. The same thing can happen if you're going to be charging your phone. If one of the wires is broken, then your phone may not recognize the cord because the electricity is not flowing through it appropriately. So if a switch is turned off on your flashlight, then no electricity can flow through it either. So that's why you refer to some of these switches as circuit breakers sometimes. But you don't always need wires specifically to create a circuit. There is a circuit between a storm cloud and the earth, in the case of lightning, and that's formed by the air in between. Air doesn't typically conduct electricity, but if there is a large enough electrical charge built up in a cloud, it can create these charged particles in the air that are referred to as ions. So ions are atoms that have lost or gained some electrons. So that just means that the atoms don't have a neutral charge. They're either positively charged or they are negatively charged. And they work like an invisible rope that links the cloud in the air to the air below it and the ground below it. And lightning will flow through the air between the ions. It's really pretty cool. Ions are very important for a lot of different concepts related to electricity, and we'll discuss those more in depth as we move forward and talk about bioelectricity in a future segment in this episode. But we really want to first understand how the current electricity flows. A current of electricity is a steady flow of electrons, and so as they move from one location to another around their circuit, they carry electrical energy from place to place. You can kind of conceptualize that like ants that are carrying leaves. So instead of leaves, the electrons have a tiny amount of electric charge. And the electricity can travel through something when the item's structure allows electrons to move through it easily. So that's why metal is more conductive. Metals like copper have free electrons, and free doesn't mean they're just chilling and floating in the middle of nowhere. It's just that they are not bound super tightly to the atoms they normally belong to. And those electrons can flow freely through the structure of copper or these other metals, and that allows an electric current to flow. In something like rubber, though, which is not really conductive, the electrons are very tightly bound to the atom it is originating from. So it's not really a free electron, and because of that, electricity doesn't really flow through rubber. So conductors that let electricity flow freely, like metals, are said to have high conductance and a low resistance. Insulators are the other type, like rubber, that do not allow high electricity to flow, and they have a low conductance and a high resistance. So when we talk about the resistance, it is not really allowing the current to flow. It's resisting the flow of electricity. It's not conducting that current. And for electricity to flow, you also need something to push the electrons along the line. That is usually referred to as an electromotive force, or an EMF. A battery or a power outlet, either or, can create an electromotive force that makes a current of electrons flow from one location to another. And that electromotive force is most typically referred to as voltage. We're going to go on a quick break, and when we come back, we're going to talk about the concept of electricity within health and wellness, starting with TENS units for therapy. Stay tuned.
Tired of searching the vast jungle of podcasts? Now listen close and hear this out. There's a podcast network that covers just about everything that you've been searching. Hey! The Golden State Media Concepts Podcast Network is here. Nothing less than a podcast bliss with endless hours of podcast coverage. From news, sports, music, fashion, cooking, entertainment, fantasy, football, and so much more. So stop lurking around and go straight out to the Golden State Media Concepts Podcast Network. Guaranteed to fill that podcast itch. Whatever it may be. Visit us at www.gsmcpodcast.com. Follow us on Facebook and Twitter, and download us on iTunes, SoundCloud, and Google Play.
About current electricity or electrical currents. Now that we have an understanding of what electricity is and how it works, we're going to discuss some trends in health and wellness. First up is the TENS unit. If you are not familiar with a TENS unit, it is short for transcutaneous electrical nerve stimulation. And it's a battery-operated device that some folks use to treat pain. I personally have one of these and have found it to be immensely helpful over the years. So TENS units work by giving you these small electrical impulses into your body via some electrodes, those little knobs that attach to the sticky pads that go onto your skin. So those electrical impulses go ahead and flood your nervous system, and it helps to prevent or reduce the amount of pain signals that are going to your brain and spinal cord. So the same electrical impulses also stimulate your body to produce some natural pain relievers referred to as, you guessed it, endorphins. So we're going to talk a little bit more about the TENS unit and what you can use it on and so on and so forth. TENS units look widely different depending upon which type that you get. I've seen some giant ones, especially way back in the day when my mom first got one, and now they're pocket-sized, really. I've even worn mine on a plane and also at conferences in which I'm having to walk around a lot. No one else can tell that I have them on, so it works pretty awesomely. TENS units can help you with period pain, and a lot of them are marketed specifically for that right now. I've seen a lot of those online. You can also treat symptoms related to labor pain, post-op pain, joint pain, and neck and back pain. I primarily use mine for neck, joint, and back pain, but they are actually pretty effective for period cramps as well. They can also alleviate pain that is related to endometriosis, arthritis, multiple sclerosis, fibromyalgia, spinal cord injuries, diabetic neuropathy, and sports injuries. So there are several different use cases for this. And I think that arthritis is really one of the top ones up there because it really helps out a lot. I also tend to get tendinitis in my left arm, and it helps that out quite a bit. You just attach the electrodes and roll it on out. TENS units have controls too that help you administer the appropriate level of pain relief for you. So we all have different pain thresholds, and different parts of our body are more or less sensitive than other parts, even within individuals. And you can make these changes in the amount of pain relief you need by altering the electrical current aspects, like the intensity. So you can change the intensity of the electrical stimulation to be very high or very low. The one that I have right now goes from 1 all the way up to 20. It also has a dial to change the duration. And by duration, we mean the number of microseconds that the current enters the skin for during each pulse. So each transmission of that electrical impulse. So I have 6 different settings on mine, and some of them feel almost like someone's giving you a back massage where they are just kind of thumping or chopping onto your back, and then other types feel more like pinpricks. It just depends on what you're into. So I have 6 different settings that are defaults on mine, and I can also tell it how long I want it to be on. So the default for that is 20 minutes in the unit that I have. You can also adjust the aspect of frequency. So frequency is the number of electrical pulses per second. High frequency pulses are anywhere from 80 to 120 cycles per second, and that's generally for acute pain. Low frequency pulses are about 1 to 20 cycles per second and are good for treating chronic pain. Those are just the general guidelines. Now, I have tried my TENS unit on myself, and my ex also used it at one point when he was having back pain. I have to crank it way higher than he cranks it. That's just the way it is. He is over a foot taller than me. He is in really good shape. He's in better shape than I am, just be perfectly honest with you. And it was just very different for him. He ended up not enjoying it because even at the lower settings, it hurt quite a bit. Now, you also want to keep in mind that if you are going to use a TENS unit, you need to pause or stop the impulses that are going through there, those electrical impulses, when you're trying to move or reposition the electrode adhesive pads. Otherwise, you're going to zap yourself, And getting zapped on your back might not feel that rough, but if you have that on your fingers, you guys, you're gonna yelp, depending on how high up it's already turned. So definitely, when you're gonna move them, make sure that you turn it off first. We made that discovery the hard way the first time, so just keep that in mind. But some of the benefits of this device is that the TENS unit is non-invasive in its approach to helping you relieve pain. I don't want to have to take NSAIDs all the time. Even if NSAIDs are relatively innocuous, I just don't want to be putting extra pills into my body that I don't need to be, necessarily. And you guys know from our previous podcast that I'm also very pro modern medicine. I am on Prozac for anxiety and depression, but the Prozac is something that I've not found a real alternative for yet, and it helps to level me out. Whereas with the TENS unit, I found that to be a really good alternative for the NSAIDs for me. And for me, it also tends to be more effective than the NSAIDs. So that is really nice. This is also particularly helpful if you're having to take more serious pain medications, because some of those can be addictive and they can cause adverse side effects or even have interactions with other medications that you may be taking. TENS units are also really great at this point in history because they're small and portable and really discreet, you guys. Like mine is half the size of a deck of cards, to be honest. It's very, very small. I can easily fit it in the pocket of some women's trousers for my suit, and people have no idea that I'm even wearing it. I can easily stick it in my jacket pocket, and I carry small purses, like ones that are about the size of a birthday envelope or so, and a birthday card envelope, and the type that you're typically still allowed to bring into most venues, even if it's a large venue for shows and stuff. So for me, I can easily fit that even in my tiny purse. They also have such wide applicability that if you are using them for period cramps, no one's really going to be able to know. It's not like they're going to be able to see the electrodes. Maybe they'll be able to see the cord if the cord is going from the unit that's in your pants pocket. But overall, it's super duper discreet. They're really convenient, and some of them even can clip onto a belt. That way you can have immediate access to pain relief throughout the day. And it's not something that's super visible for folks to see that you're doing at your desk. You can go ahead and stick it in your pocket or clip it to your belt and run the electrodes up the back of your shirt or the front of your abdomen if you need to, wherever you are experiencing that pain. And just go ahead and control it from the little remote portion. Now, there are some possible side effects of TENS units, but it's safe for most folks to use them without experiencing any side effects. The electrical impulses that are emitted by the TENS unit may produce some buzzing, tingling, or prickling sensations that certain folks may find uncomfortable. Other folks might be allergic to the adhesive pads, so keep that in mind too. A lot of times, though, these adhesive pads are able to be changed out and are interchangeable with different types. You're not stuck with one brand. So you may be able to find a kind that you can use that has an adhesive material that is not going to break you out. If you use these and you get some skin redness or irritation, you can simply switch to using some hypoallergenic ones. Do definitely make sure, though, that you never place the electrodes on the front of your neck or on your eyes. If you place the electrodes on your neck, it can lower your blood pressure and cause spasms. Remember that lowered blood pressure can also cause you to pass out. If you put them on your eyes, the electrodes can increase pressure within your eye and possibly cause an injury. In general, it is recommended to not place these items above the heart level. So you don't want to be putting them on your face or your head or anything like that. If you are pregnant or you have epilepsy, heart problems, a pacemaker, or any other type of electrical or metal implants, then you should generally avoid a TENS unit treatment unless your doctor advises its use. If you have questions about that, hit up your doctor. Pregnant women in particular should not use it in the abdominal and pelvic regions, but your doctor may have different thoughts on using it on other parts of your body. It's just important to speak with them specifically first. People who have epilepsy should not apply the electrodes to the head or neck because it may induce seizures. So each of these different types of medical issues have different components regarding why it doesn't work or why it's inadvisable to use them for those folks. But it may be limited to a certain part of the body. So talk to your doctor about it and see if that is right for you. We're going to go on a quick break, and when we come back, we're going to talk about the efficacy of TENS units and also talk about another type of technology referred to as frequency-specific microcurrents. Stay tuned.
The GSMC Life and Happiness podcast takes you on a journey of exploration. We'll discuss tried and true methods alongside the latest trends of how to best live your life to its fullest and happiest. From psychology to meditation, science to self-help books, the GSMC Life and Happiness podcast will help you to discover what makes you happy and how you can live life being the best you possible. Download the GSMC Life and Happiness podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
Before the break, we were talking about TENS units. So they are little bursts of electrical currents in your body that can help you with pain relief. TENS stands for transcutaneous electrical nerve stimulation, and it helps to promote endorphins being released in your body and also reducing your nervous system's ability to transmit pain signals back to your brain. So we talked about some of the risks and who should avoid it. So now let's get down to does it work before we move on to another type of electrical current technology. So with the TENS unit, it is just really variable depending on the different types of research. So one study found that TENS unit treatment provided temporary relief for folks with fibromyalgia while the machine was in use, but it didn't necessarily provide it after the use of the machine was completed. There is a lack of strong clinical evidence for its effectiveness, but it is a low-risk pain relief option for many folks. And remember that not having a lot of clinical evidence doesn't necessarily mean that it doesn't work. It just means that for its efficacy, we need some more studies. But they have found in some studies that there are several factors that can influence how effective TENS unit treatment is. First up is tolerance. They have performed some research and found that folks who use one on a daily basis at the same frequency and intensity can ultimately develop a tolerance to the treatment. So they're not going to get the same amount of pain relief after a while that they did when they first started using it. To prevent that from occurring, you can alternate between low frequency and high frequency within each treatment session. Or you can gradually increase the intensity or the duration on a daily basis. You can also work on the stimulation intensity. There is a range of intensities of electrical stimulation that can also account for some of the differences in the research findings. In a 2014 review, they found that high-frequency TENS units treat pain more effectively than low-frequencies did, and many studies have found low-frequency TENS units to be ineffective. So overall, it's the frequency that may be a lot of the issue. So since high-frequency TENS units are more effective with pain relief, a lot of experts recommend that people apply the highest intensity TENS that they can tolerate. The type that I have is a higher intensity than a lot of those that are on the market for cramps for your period, because I did not buy mine for period cramps. I bought it for muscle pain and everything related to scoliosis and so on and so forth. So it's a little bit different for me. Keep that in mind if you're looking to purchase one, and definitely speak with your doctor as well. For the electrode placement, it works best if you put the electrodes on acupuncture points. Acupuncture is something that helps stimulate your nerves beneath the skin at specific locations using needles. So experts think that this assists your body in producing endorphins. There was a review of TENS units research, and they found that folks who receive the TENS through acupuncture points may experience a reduction in pain. I think that's super cool, and it's a neat merger of modern medicine and traditional Chinese medicine. So that's super neat and holistic in my book. So how long does pain relief last, though, if you use a TENS unit? Well, that can vary. Some folks report that their pain returns as soon as they turn off the device, and others say they have an adequate level of pain relief for up to 24 hours. One study in 2012 reviewed some other studies and found that the duration of pain relief tended to increase with more repeated TENS unit treatments. However, as we discussed with tolerance, that repetition can also increase the likelihood of building up a tolerance to the treatment. So it really just depends. In my experience, it works really well for me for back pain, especially that related to scoliosis and stress and tension in my shoulders and back, and hip pain in my lower back and hip area. So for me, when I use it, it actually helps me to relax enough to go to sleep. It relieves a lot of the pain, and when I wake up in the morning, I don't hurt as much as I typically do. So for me, it's pretty effective, and granted, I am not going to be the exact same as everyone else. None of us are. Some places will let you try a TENS unit before you purchase one. My mom got her first one from her chiropractor, I do believe. I actually purchased one at a forensic conference. So you can find these in many different places. They happen to have a lot of medical legal types of materials there, so you could buy microscopes and textbooks and things like that at the expo component. But you should definitely speak with a doctor about it first. They very well may be able to help you try one first, too, to see what frequency is really working best for you and whether you're even comfortable with it. Because remember, some folks don't like that pins and needles tingling effect. I really like mine though, and if you have a lot of pain and you need a different type of pain relief, or you're looking for something that's less invasive than other types, or is even meant to be a replacement for some type of medication like NSAIDs, I encourage you to speak with your doctor about it and see if it's right for you. Now let's talk about frequency-specific microcurrents, or FSM. FSM is a specific new technology that manipulates the electrical currents that are already existing in our bodies. So other devices that use electricity, like electrical stimulation, like the TENS unit, or also an E-stim unit, FSM is going to instead utilize lower levels of electricity that aren't really felt by the body. The current is instead used to mimic your body's own electrical nervous system. So your body does have its own electrical system that operates and takes those nerve impulses throughout your body. It tells your muscles to move and things like that. And by employing that type of current, they believe that it can help stimulate your body's own repair systems to help encourage it to heal itself. Some folks use this for tendons or ligaments or muscle repair, or even concussion recoveries or chronic illnesses. It is used at the Cleveland Clinic as well to treat adults and kids who are experiencing a wide variety of conditions or symptoms. So they have been using them for a bunch of different things so far that you might not even expect, such as shingles, burns, kidney stones, IBS, asthma, fibromyalgia, diabetic neuropathy. Those two we are familiar with from the TENS unit as well, but also swelling or inflammation of tendons, acute and chronic musculoskeletal injuries, acute and chronic nerve pain, chronic fracture and bone pain. You can also use it for viscerally referred pain, concussions, headaches, plantar fasciitis, sports injuries, and even wounds. Now, these are used at the clinic in a healthcare professional medical setting. So don't try to just order an FSM or a TENS unit online and try to do this yourself and apply it to everything. You want to talk to your doctor to make sure you're using the machine correctly, finding the correct current to promote healing in the area in your body that is experiencing problems or pain, and to get you into optimal health and wellness performance. Now, the frequency that's used is specific to the tissue that is involved, and they have found frequencies for nearly every type of tissue in your body. But that's one big reason why it's important to consult a doctor about it first, rather than just trying it on your own. Because remember, you're not really going to be able to feel these impulses like you could with a TENS unit. This also works differently from a TENS unit in that it increases the production of ATP in injured tissues, or at least it's believed to do so. And ATP is that major source of energy that are required for cellular reactions in your body. They believe FSM can increase ATP production by as much as 500% in damaged tissues. So it's a pretty cool type of device. If you like the concept of TENS units, but you are not so much into the concept of the tingling sensation, then perhaps FSM could be right for you. We're going to go on a quick break, and when we come back, we're going to talk about bioelectricity. Stay tuned.
Are you tired of the same old news? Are you sick of the seemingly endless political spin and negativity? The GSMC America's Still Beautiful podcast is a weekly news podcast covering all the top positive and uplifting news stories. We cover stories that will inspire, uplift, and remind you of the good in the world. Tune into the Golden State Media Concepts America's Still Beautiful podcast to get all the great and positive news stories of today. Download the GSMC America's Still Beautiful podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
Welcome back. Before the break, we were talking about FSM and TENS units. Now we're going to talk about bioelectricity and how it can help our bodies develop and regenerate. So, bioelectricity is about the electricity or the electric signals within our bodies, whether that be human or non-human bodies. Remember in our first two segments when we were talking about electricity and what it truly is, we discussed the concept of ions. So ions are when atoms have an unequal amount of protons versus electrons, and that results in one item having a negative charge and another having a positive one, and them being then drawn to each other. Well, in animal cells, including human cells, we have sodium and chloride ions, as well as potassium ions. And we've discussed this before in our other episodes related to sodium and how sodium-potassium ion exchange pumps work. So this type of issue in the body means that we have a negatively charged interior of our body with the sodium and chloride ions inside, and the potassium ions are being moved out. That results in a voltage of negative 40 to negative 80 microvolts across the membranes. And that tends to be about 20 times less than a watch battery, to help put that into context for you. Those electric currents are created when the ions go from one side of the membrane to the other. Without this flow of these ions creating this electric current, our hearts wouldn't beat, and our nerves would not relay signals from our brains to the rest of our bodies without it. So the ability of these ions to move in and out of these membranes is what keeps us alive, and it's referred to as transmembrane potential. That is kind of the reason why if someone is having trouble with their heart health, that they may get a pacemaker to help keep those electric currents stable, to keep our hearts beating with an electrical flow. So researchers overwhelmingly agree that bioelectric currents are integral for nerve and muscle function, but they're not entirely sure of what they do in our other tissues within the body. Some of the evidence that we first stumbled across with this came from studies of growing embryos. In 2002, a lab demonstrated that in developing tadpoles, there was a flow of hydrogen and potassium ions that helped to establish the left and right sides of the animal's body along its line of symmetry, making sure that it was as symmetrical as possible. It also was there to help correctly position the head and the tail. If these ions and this flow of electrical current were randomized, then it messed up the locations of the heart, the stomach, and other organs. So the body was not able to form entirely correctly along the lines that it was meant to. This notion that electric currents within an embryo could influence maturing cells really surprised a lot of folks who are researchers in regeneration and development. And that idea really launched the concept that bioelectricity could play a much broader role in development. So it's not just the DNA blueprint, it is also these other mysterious forces within the body, like bioelectricity. Bioelectricity was very underrated at the time, and now we see that it can even result in organs being misplaced or displaced, more or less, in your body because they don't know where to go. A lot of researchers now realize that bioelectric signals are important for everything from spinal cord development and cell differentiation to wound healing. And the concept that bioelectric signals are important really isn't outlandish. And it's odd now that we are feeling the need to say that, because we're looking at it as we know of it now. We're like, oh, well, duh, those are important. But a while back, people thought that that was perhaps absurd. And there's a lot of evidence that they may be at work outside the brain as well as within the brain. These bioelectric signals may control or influence a lot more of the human body than what we initially thought. So now we need to figure out how those signals are aligning with other cellular mechanisms beyond the ones that we have discovered so far, like organizing where our organs go. Some data that they have found so far tell us that bioelectricity has a lot of potential. We may be able to tweak cellular electric signals with different tools, and perhaps one day be able to heal wounds or help lost tissues to regenerate. But we aren't quite there yet. We are trying to look into that though, and it is truly the future that Star Trek has promised us. Studying these bioelectric signals in tissues can be really difficult though, because they have to be in living cells. They have to be in living tissues. You can't use preserved cells or samples for it. If you freeze a cell or you extract proteins or RNA to examine them, then the bioelectric signal disappears. So that makes it really difficult. We looked at this quite a bit when I took human biomechanics during graduate school, and it was quite fascinating to see how this type of data is measured and observed. It's also important to find the correct animal model for it. Many labs use flatworms because they're known to be pretty powerful in regards to regenerative properties. You can take a little tiny snip of tissue from the middle of a worm, and the worm can remake a head, a tail, guts, and other organs. It is truly wild. Biology is one of my favorite topics, y'all. But genetic manipulations in certain species of these flatworms are really tricky. And it's because of their already awesome regenerative abilities that it's difficult for us to know if changing an electric field can enhance that ability. So some labs have tried to use other systems to model this, like clawed frogs, chicken embryos, and even human stem cells to answer that question. But we don't know if the data extends across the animal world. Researchers don't think that bioelectricity is species specific. They think that it is a general principle in biophysics, and that no matter what species these animals are from, whether they be human or worm or cat, that there are these properties that are present. And in regenerating flatworms, it's found that disrupting the way certain genes are expressed can also produce two-headed worms, similar to the type that are formed when you tweak them bioelectrically. So they are still trying to test bioelectricity with modern day tools, and they're trying to bring it into the molecular age. So studying molecular biology as it relates to bioelectricity. Another way that they're doing that is by using voltage-sensitive fluorescent dyes. So that is really wild to me, you guys. I've had to get different types of scans before in the hospital that involved me ingesting dyes or being injected with a dye. And so has my mom over the years. And that's really similar to how this is working. But these are voltage-sensitive dyes that fluoresce on the screen when you are looking at the electrical gradients of frog and chicken embryos within the specific context. So the researchers are usually putting electrodes in for such experiments, but they are finding that using those electrodes are more invasive because it involves poking a hole through a membrane or by messing with the exterior of it. And it limits how many cells they can use at a time. It doesn't really provide a map of the entire animal. So using the dyes is something that seems so simple, but it's really revolutionary because then they can see in a living animal how voltage gradients were helping the embryos form and determine which side was left versus right, where the head goes, where the tail goes. So that's how they're able to see that, is with these dyes in combination with microscopes and a host of other modern tools. We are living in the future, y'all. So a lot of these genetic tweaks found that the left and right halves of a developing body really talk to each other and communicate via electric gradients that are transmitted through those ion channels referred to as gap junctions, which works kind of like how neurons in the brain are connected. There's a set of electrical connections that occurs in order for the left and right sides to communicate while an embryo is under development. And without getting those cues, the organs in your body, like your heart or your stomach, could get flipped around to the wrong side. If you like the TV show House, then you may have seen an episode or two in which someone's organs were on the incorrect side. There is a specific placement that your body generally expects, or that a human body is generally blueprinted for. So this is pretty fascinating. It may not be the only reason that the organs would be flipped, but it is a reason that organs can be flipped in the human body. We're going to go on another break, and when we come back, we're going to talk about how bioelectricity could help us to fight cancer. Stay tuned.
GSMC Beauty Tips Podcast gives you advice on everything from hair to fashion to skincare products. We'll talk about the latest trends in makeup, hairstyles, and anti-aging remedies. And we'll cover all of the newest fashion trends. If you have an interest in or questions about the beauty trends that might work best for you, the Golden State Media Concepts Beauty Tips Podcast has got you covered. Download the GSMC Beauty Tips Podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
Welcome back. Before the break, we were introducing the concept of bioelectricity, how it works and how it can truly impact development and regeneration in humans and non-human animals alike. Now we're going to talk about how bioelectricity might help us fight cancer. So first up, your movements, your perceptions, and your thoughts are controlled by electricity, as we discussed in our last segment. Even our cells are communicating with each other via this bioelectricity communication network. That's how all of our cells communicate with each other. Bioelectricity isn't the same as the electricity that turns your lights on and off. It's based on electrons, negatively charged particles flowing within a current. The human body and your brain run on a different version, and it is the movement of these positively charged ions of elements like potassium and sodium and calcium. So these ions are a little bit different, but they are very similar in principle. And that's how all signals travel within and between the brain, and every organ and every component that's related to perception and motion and cognition. It's how we walk and talk and think. And it also helps our cells communicate with them what to do, how to arrange different organs in development, and also how to decide whether the systems they're a part of are healthy or not. I think that is truly fascinating, and you can also measure voltage gradients in different organ systems. In as early as the 1920s, doctors like Louis Langman were offering folks at his ward at Bellevue Gynecological Services a strange diagnostic approach for cancer. He would place 2 electrodes, one into the vaginal canal and another onto the pubis, and then measure the electrical voltage gradient between the cervix and the ventral abdominal wall. If he found a marked change in the gradient, he would recommend a laparotomy to see if his suspicions were justified. This sounds really weird and almost like mad science, but it was rather effective. He tested 102 cases that had fluctuations revealing a significant shift in that voltage gradient, and 95 of those 102 abnormalities were confirmed to have malignancies. That is a 93% success rate in that test. So the exact locations of the cancer varied, but they were often identified before the woman had even started experiencing obvious symptoms. So using bioelectricity was helping us even in the 1920s to get ahead of the curve. And this Langman and some of his friends were a part of a very small group of scientists that were looking into the electrical properties of human tissue. And they believed that all things, animals and plants, were controlled by electrical fields that could be measured and mapped. Now, they were correct, but their findings were not very well understood for decades. It wasn't until 1949 when Alan Hodgkin and Andrew Huxley discovered how ions help electrical signals hop across nerve cell membranes that folks really started to get behind this. Hodgkin and Huxley's discovery was a huge breakthrough, and they won a Nobel Prize for it later. You would think that that would have initiated a wide field of new research, but they really didn't. They discovered that mechanism, and then in 1953, Watson and Crick announced that they had discovered the double helix structure of DNA. As a side note, many other researchers were also involved in that, such as Rosalind Franklin, but James Watson and Francis Crick were the ones who got ahead of everyone in that announcement within the Western Hemisphere, honestly. And so they got the credit for it. So I'm not saying that Watson and Crick actually discovered the double helix structure of DNA. I am just saying that history awarded them the credit for it. The overarching point is that this new revelation in biology really stole the thunder that had been associated with bioelectricity, and then folks didn't really care about it anymore. We became more focused on genetics than we were on bioelectricity. It was also difficult back then to study ion flows in cell types without killing them, and that really made it incredibly difficult to study bioelectricity. In 1976, Erwin Neer and Bert Sackman developed a tool to do that, though. It allowed scientists to watch these ions drift in and out of neurons. They referred to it as a patch clamp technique to discover the channels that allowed ions to permeate cell membranes. Over the years, we have made many more developments in the field of bioelectricity and also in just measuring and visualizing different elements within the body that we couldn't 50 years ago or 100 years ago, even if we already knew about bioelectricity 100 years ago in 1920. But there are a lot of new ways we can apply this to. And that's where cancer comes in, really. Cancer's been referred to as a wound that doesn't heal. New blood vessels form both as wounds heal and as cells turn malignant in the body. And there are changes to the electrical signals in the body in both cases. But in cancer, those signals never stop. Just like Langman and Burr suspected in 1920, cancers can be detected by their disruption of widely distributed bioelectrical properties of the body. These disruptions can be detectable at locations far away from the tumor itself. Burr also showed that if you implant a tumor into an animal, its body's electrical signaling would almost immediately go haywire. Cancer is really beginning to be viewed now as being more of a failure of communication. So the field of information that tells your cells what to do and how to act or function is really misregulating. And these cells forget that they're part of a larger whole and just treat the rest of the body as an environment to be exploited for resources to feed themselves. It's a truly unique perspective, and a very large paradigm shift from how we have been viewing cancer for decades. We just thought of cancer as being an accumulation of genetic damage, just that the cells weren't going into apoptosis, and it was just uncontrollable cell division. But this bioelectrical approach of thinking about it on communication terms is helping us view it in a wholly different way. There may be more to this than we initially thought. Perhaps cells that can no longer communicate normally with the body's network are relevant in how cancer behaves. And that is what Michael Levin at Tufts University is looking at. And there's growing evidence that he may be correct. These are electrical fields that are generated by ions pumping across your tissues in your body, send these cues to the cells to start migrating. That's a really important factor in how cancer spreads throughout your body. So folks have been studying the role of specific types of sodium channels in breast and prostate cancers specifically. These tend to proliferate in cancerous cells, and they make them more electrically active than the body's normal control mechanisms can manage. Then they can end up invading other tissues and metastasizing. So doctors are now exploring whether cancer could be reversed by controlling the bioelectric communication among and between cells. In 2013, Levin's group found that you could prevent or reverse some tumors in tadpoles by using drugs to target their bioelectric signaling. Those drugs could turn cancer on and off at a distance by treating the environment rather than the cells themselves. In 2016, they were even able to restore normal bioelectric signaling in frog tadpoles that had tumors. These tumors had grown, spread, and formed their own blood supply until Levin added some new light-activated ion channels along with gene therapy. That prevented the cells from uncontrollably dividing, and then they reverted to a healthy state after the tumors had already formed. The cells just stopped being cancer cells. This would be really difficult to do in humans right now because gene therapy is still considered to be experimental, but it's very promising in the future for electricity to be able to treat cancer using our own bioelectrical fields and environments within the human body to treat and even reverse cancer. Thank you for listening to the GSMC Health and Wellness Podcast, brought to you by the GSMC Podcast Network. I'd like to ask that you please subscribe to the show, and writing a review always really helps us. Also, if you could please follow us on Facebook, Twitter, and Instagram, I'd appreciate it. Thank you kindly, and have a good night.
You've been listening to the Golden State Media Concepts Health and Wellness Podcast, part of the Golden State Media Concepts Podcast Network. You can find this show and others like it at www.gsmcpodcast.com. Download our podcast on iTunes, Stitcher, SoundCloud, and Google Play. Just type in GSMC to find all the shows from the Golden State Media Concepts Podcast Network, from movies to music, from sports to entertainment, and even weird news. You can also follow us on Twitter and on Facebook. Thank you, and we hope you have enjoyed today's program.